Alright folks, so in today's video we are going to do some power tests and spectral purity tests of this, the Radioddity GS-10B. It's a tri-band handheld ham radio that has all the bells and whistles. It does 2 meters, it does 1.25 meters or the 220 band, and it does 70 centimeters or 440 megahertz. For the power test, we have the radio connected to the NSA RS4 power meter. It has a range down here for 15, 30, and 300 watts, I believe. I can't read that. Yeah, that looks about right. And it has a power function and an SWR function. So we are set on power function and we are set on 15 watts. Also, we have an MFJ dry dummy load connected right here. The radio output is expected to be 10 watts on high. I took a look at the website and I took a look at the manual and I did not see any specifications for any of the power settings other than up to 10 watts. So we don't know what to expect from low and medium. We're going to test it on all 3 bands, and we're going to do that right now. But before we do, I did want to say that I was contacted by the fine folks at Radioddity, and they said, would you like to review this radio? And I said, yes, because I like to review radios. That means they sent this to me free of charge in exchange for this video review. If you're the type of person who is triggered easily by sponsored content on YouTube, I suggest you go watch some cat videos. When you're ready to build, PCBWay.com is ready to deliver. With expert PCB manufacturing, assembly services, and worldwide shipping, PCBWay.com turns your designs into reality, quickly and affordably. From the first prototype to final production, experience quality you can trust and support you can count on. Build better, faster, smarter, only at PCBWay.com. Okay, so we zoomed in a little bit just so you can see this. Hopefully we can see everything okay. This second button down, I think they call it the PF2 button. When I hit that, I can change power modes. Right now it's on L, and that is for low power. So let's just go ahead and key up and see what we see. And that low power, it says ATX, I guess that means VFOA. It looks like it's right around 5 watts. Now we are using the lowest scale, the 15 watt scale. That's the first white one when you're going up from the bottom. So let's go ahead and let's change this to medium and see what we get. And that's just over 5. So that looks like it's really around 5.5, 6 watts. Again, I'm not 100% sure what to expect. Let's go to high. We are now on high setting. Let's go ahead and key up. And that looks like it's like 7 watts. Let's do that again, but it's not 10. All right, what we want to do now is we want to go to 2, 2, 4. And this puts us in the 1.25 or 220 band. And let's go ahead and key up on low. So now we're back to low. And that looks like it's around 3 watts. Yeah, if I count right, that's about 3 watts. All right, so let's go to medium. And that's right on 5. So on 2 meters, low was 5 watts. On 220, medium is 5 watts. So there's a little bit of a consistency issue there. Now, it is not atypical to see lower power output on a radio that is a tri-bander on the 220 band. Let's see where we left off. Now we are on high. Let's see what we get here on high. And that's just below 10 watts. So it's like 9.5, 9 watts or something like that. So it's a little jumpy around. Let's go to 3. Oh, I did not mean to do that.
4, 3, 2, 1.
Okay, now we are in the 440 band. And what we are going to do is we are going to go to low power. And that changed my... Oh, I changed to VFO mode. I want to be in VFO mode. Okay, I don't know why I changed my frequency.
3, 4, 3, 2, 1. 0, 0.
I must not hit those zeros. Okay, so here we go. We are on low power. Let's go ahead and key up and see what we see. And that's right around 3 watts. medium. Let's see what we see. And that is right around 5 watts, maybe just a smidgen over. Let's go to high power. And that is like 7.5 watts. Okay, so what we saw is that the power levels vary pretty good between the different bands. I would like to see some more consistency there. Am I upset? No, I kind of expect this out of radios. Keep in mind, this radio is like $47, $48. I think you have to add shipping onto that. That's what I would expect. Okay, so this is the box, and it did have the radio in that box, but I took the radio out. Here's the instruction manual. We'll take a quick look at an electronic copy so it's a little easier to see. I'm going to take this with me everywhere, but the instruction manual isn't very complete. It came with this USB wall wart. Look at that, it's green inside. And it came with your standard Baofeng-esque antenna. Let's take a look and see what that says in there. If you take a look at that, that looks like it is a 2 meter and 70 centimeter antenna. This is not a tri-band antenna. Tri-band radio probably should come with a tri-band antenna. Take a look here. This is the FBI style ear and mic jack. It comes with a USB-A to USB-C charging cord, which is pretty cool. So you could use it with this. I think they refer to that as a dock in the instructions. And it comes with a pocket clip. I'm not sure if I'm going to put that pocket clip on there or not. I haven't quite seen one like this before. Taking a look at the radio, it does have a USB-C charging port on the bottom. Super handy in today's world. Yeah, let's just pop this baby open. And it should be the K-type adapter, and it is right there. It did not come with a programming cable. They might have sent me one separately, but I don't see it. It's not in this box, so I don't think I have one. I mean, I have one, but I don't think they sent me one. I'll have a link to this below, but this is the product page from the Radioddity website. If you take a look here, it says Early Bird Bundle. Note, discount code not allowed on sale bundles, but this bundle is the radio plus the Radioddity V100B airband and 1.25 meter antenna set. So I guess for $47.99, you can get these antennas right now. Pick your power plug. But it says here the early bird offer, the free antenna set, is good till 9/23 through the 30th. So that means that after the 30th, you won't be able to do this. Now here it says powerful 10-watt ham radio. Transmit up to 10 watts for stronger signals. We did the power test, so you saw the results there. 2,500 milliamp battery. That's pretty good. And what I wanted to do is I wanted to come down here and look at the specs. Here it says with 10 watts of power and multiband support, including UHF, VHF, FM, and airband, 1.25, 1 meter, and NOAA. The GS-10B keeps you connected anywhere. Down here under specifications, you can see transmission frequency. So it transmits anywhere from 136 to 180, 330 to 520, and 220 to 260. So you'll be able to transmit out of band. Good for you. I guess people would ask me, hey, does this thing work on GMRS? And I guess the answer is technically yes. Is it allowed? Well, probably not. The other thing is that when you look at channel spacing down here, it says 2.5 kilohertz wide, 12.5 kilohertz narrow. Many of the channels on GMRS require 20 kilohertz wide channels. This means that you will have attenuated or distorted signals on receive, and you will be transmitting out of your channel. Here it says it has an upgraded 28650 rechargeable cell. Well, a 28650 would mean that the battery is 28 millimeters in circumference, and it would mean that it's 65 millimeters tall. O means it's round. This battery doesn't look like that to me, but maybe I'm missing something. There is an app that you can install, and it has iOS and Android support via Bluetooth. That's pretty handy. Now, up here on the site, it says FCC ID. Right here, 2AN62 GS-10B. Let's copy that. Let's go over to the FCC.io website, type in our FCC ID, and do a quick search. And here it is, display records. So there is some detail here. Okay, if we click on here, let's take a look at this one, FCC difference description. So here you go. Office of Engineering Technology, subject to explanation of differences between product types. So this FCC ID is used for model number GS-10B, GS-10B Pro. The GS-10B Pro is not out yet, so expect to see that at some point in time. Otherwise, they would have never filed this. Let's see, they also filed FCC short and long-term confidentiality request. To whom it may concern provisions of the Commission's rules, we are requesting the Commission withhold the following attachments as confidential documents from public disclosure indefinitely. They are asking to withhold this block schematic, the schematic diagram, the block diagram, operational description, and the parts list. And they ask for that to be an indefinite something or other. That's a shame because I like looking at those. Okay, so we are going to show the test configuration right now. So I have the radio that goes into the big ass attenuator. This is 100 watts, 40 dB attenuator. And I use this directly connected to the radio to drain all the power out so that we have a very low power level coming in. After that, we have a smaller 10 dB attenuator. This is going to be 50 dB of attenuation. Now, we are going to use the internal attenuator to add another 10 dB, which is going to take us down about 60, and that puts us really close to our negative 25 dBm input power level that we have on the Tiny SA. The reason we do that, the reason we go through all this trouble, is because we want to be as close as we can to negative 25 dBm. That's where this is its most sensitive. When we test on high power, we are going to add an additional 3 dB of attenuation to get us there. In both configuration settings, we're going to be about negative 23 dBm, and that's going to be fine. Okay, we are going to run over the rules real quick for harmonic emissions. And the reason I do this is because a lot of people don't understand these rules, or they misinterpret these rules, or they apply them incorrectly when they do their measurements. You will be surprised at how often people reach out to me showing me pictures of their Tiny SA asking if their radio is clean. So it says the mean power of any spurious emission from a station transmitter or external power amplifier transmitting on a frequency between 3 and 225 megahertz must be 60 dB below the mean power of the fundamental. Well, this radio does transmit on those frequencies. For a transmitter having a mean power of 25 watts or less, that is this radio, because this radio only goes up to 10 watts, give or take. The mean power of any spurious emission supplied to the antenna transmission line, that means we measure at the output of the radio, must not exceed 25 microwatts. So at the bottom, you can see down here, I did a little math and I converted 25 microwatts to negative 16.02 dBm. Now, a lot of people say to me, Ape, that's pretty low, so even if it exceeds that, it really should be okay. Well, it's not okay because the rules say it's not. That's problem number one. Problem number two, an S9 signal, which is pretty daggone strong on VHF and UHF, is actually negative 93 dBm. All right, it says that once you do not exceed that 25 microwatts, the signal must also be 40 dB below the mean power of the fundamental emission. The fundamental emission is the transmission frequency, the one that you are transmitting on, but need not be reduced below a power of 10 microwatts. Transmitters built before 1977 in April are exempt. Okay, so we got some very exciting stuff here. We are connected to the computer, and you can see the screen of the Tiny SA over here somewhere. Okay, what I'm going to do now is I'm just going to go through the configuration for the test. So I'm going to go to my main menu, and then I'm going to go to measure, and I'm going to pick harmonic, and we are going to do our first test on 146.52 megahertz. It's going to ask us for a span. When we do this test, the screen is divided into various sections at each harmonic interval. We're just going to go ahead and pick 10 megahertz for that. And let's wait for this thing to refresh. And now you can see those vertical blue lines dividing the screen. The next thing that we are going to do is we are going to set our level. And when we do this, we come into external gain, and we have negative 50 dBm of attenuation. And so now we can see our screen starting to come together. I'm going to come over here and I'm going to go to display. Let's wait for that screen to refresh. And let me go back so you can see under display, we have something called draw line. I'm going to pick draw line. I'm going to go negative 16.02 dBm. Now that is a threshold for this test. Okay, the next thing I'm going to do is I'm going to go back, and then I'm going to go into a level, and I'm going to go to attenuate, and then I'm going to change this from auto to normal. I think it was normal. And we are going to do 10 dB of internal attenuation. And so what that means is that we have on our configuration here 60 dB of attenuation. Now, let's see if you can see my mouse. You should be able to see it right here. You can see right here, this says a 10 dB. So that's telling me that my internal attenuator is set for a level of 10 dB. All right, let's go over to our radio and see what's doing on that. 1,
1, 4, 6, 5, 2, 0.
Okay, so now we're set for our fundamental frequency of 146520. And we are set for low power. So let's go ahead and key this baby up and see what we see. Now we're going to give this a second to settle down, but I can tell you right now that doesn't look good at all. As a matter of fact, that's a pretty hardcore fail right there. So 2 meters, low, no good. All right, we're going to drop that down, and then we are going to change our power level to medium. We are on medium right now, so let's go ahead and key up. Now, our fundamental frequency should settle out somewhere around 35 dBm. Oh, 37, so it's around 5 watts, 38.1. And when we take a look at this, again, that's a pretty hardcore fail. So we have harmonics on 2, 3, and 4 that all exceed our threshold, and they need to be 40 dB down at these power levels on these frequencies from the fundamental. So if you take a look at this, you can see in the data table, the delta for marker number 1 is only 35.8, 35.9. It's moving back and forth dB down from the fundamental frequency, and that would be a fail there as well. We take a look at marker number 3, it's negative 40, so that one would be 40 dB down, which is good, but it's still exceeding that blue line threshold. That's unfortunate, because that would mean that this radio is not legal for use on these bands. The next thing we are going to do is, well, I don't want to, let me go ahead and add the, so what I want to do now is I'm going to add some additional attenuation for testing the high power level on 2 meters. So just give me 1 second. Okay, the attenuation is in place, but we need to go back here in our menu, and we need to go back, and then we need to go back into level, and we need to change our external attenuation setting to negative 53 times 1. Okay, now we're back at our radio, and we are on high power, and let's go ahead and key up. Okay, and we're at 38.9 dBm at our fundamental. If we take a look at marker number 2, it's only 35.8 dB down, so it doesn't hit that 40 dB threshold. It looks like harmonics number 3 and 4 do hit that 40 dB down threshold, but they exceed the minimum threshold. And again, high power, not legal for use. Okay, what I need to do now is I need to reconfigure the test to test on 1.25 or the 220 band. So let me go ahead and do that now. I'm going to go back, and I'm going to go to measure, and then I'm going to pick harmonic, and we are going to go at 224 megahertz. And for our span, again, we're going to do 10 megahertz wide. Okay, so we are going to test high first. So let's go into level. We're going to leave our external, we're going to change our external attenuation to negative 53. And then we are going to go back, and we are going to go into display, and we're going to draw our line, negative 16.02 times 1. And then the next thing we are going to do is we are going to go back into level, and we are going to attenuate manually at 10 dB. Okay, we are ready for the test. So I'm going to go to the radio, and what I'm going to do is I'm just going to go into 2, 2, 4. And we are on high power, so we're doing the high power test first. And that looks pretty good. It'd be pretty hard to complain about that. It's as clean as it gets. So I wonder why it would have some trouble on 2 meters and no problems at all on 440, but that's the case. Okay, what we're going to do is we're going to take that extra attenuation that we put in here out. Okay, we have done that, and we need to go back in here. We need to go back, and we need to go to our level settings. And then we need to change this to -50 times 1. Okay, now we are going to change our power setting to medium. And there we are. And then now we're going to key up. So when we do this, this looks like 8, and once it settles out, is below the line. Harmonic 2 is not exactly, let's take a look at that. It's 224 away. Okay, no, that's right. And it's 61 dB down. So it appears to be clean there as well. So let's change our power level one more time. We're going to go to low. Now we're set for low. Let's key up. Give it a second to settle down. And it looks good. You know, it's really disappointing that we had the problem on 2 meters because that does make us legal to use on that particular band. But for 220, it looks fine. And there is no harmonic requirement on 70 centimeter band, so we're not going to test that. Anyhow, that's going to wrap it up. I'd like to say thanks, Radioddity, for sending this radio to me for my consideration. Thank you for watching, everybody. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below, and I'll do my best to respond. As always, thank you for watching.